So welcome back, everyone, to Griffith Observatory. So happy that you're here this afternoon as part of our Apollo 11 50th anniversary celebration. It's just about 50 years ago, almost exactly, within about 15 or so minutes, that astronauts first landed on the moon in 1969, and of course we're here to celebrate that all day. We have a series of talks. We've had a couple about Apollo and about the moon. This one is about whether the moon landings were a hoax or not a hoax. And this talk is usually presented by one of our colleagues, Dr. David Reitzel. He is homesick with terrible bronchitis. So we're going to be filling in for him and doing the best. And I just want to thank my colleague here, Patrick So, for dressing the part as an Apollo engineer here on the anniversary.
I don't have my pocket protector here.
Yeah,
so.
And your slide rule. Yeah. So this is Patrick So, he's the theater programs manager. I'm Dr. Laura Danley, I'm the curator of Griffith Observatory, and we welcome you and we thank you. We thank our taxpaying citizens of the City of Los Angeles. Griffith Observatory is owned and operated by the City of Los Angeles Department of Recreation and Parks. So if you pay your taxes, you're helping support this wonderful municipal observatory. And we also thank Friends of the Observatory, our sister membership organization that helps support our programs, including our 5th grade school field trip program. So if you aren't a member, think about becoming a member. If you don't think you're ready to become a member, there are little bins around the building. This is a free presentation. Whatever you think is the right admission, you can drop it in one of those bins, and I know that the 5th graders of Southern California will be grateful. So before I begin today's presentation, let me just say also at 2 and 3, we have 2 more presentations about the future, the near-term future, the Artemis program, which is NASA's follow-on to Apollo. How many of you have never heard of the Artemis program? So, okay, that's about the same amount in previous audiences. And then our long-term future, will we someday live on the moon? And that talk is at 3. So we hope you'll come back. All the folks doing the presentations today are part of All Space Considered, our first Friday of the monthly astronomy program. So if you want to know more about what we do, you can follow us at All Space Considered. So moving on, hoax or no hoax? Some people think it was all done on a soundstage. And I'm not even going to ask you if you think it's true, because I'm sure that everyone in this audience knows that it was real and not a hoax. But we're going to give you some of the arguments that you're going to need to talk and convince your perhaps less informed friends that this is not what happened, that in fact we really went to the moon, really landed people. And I'll just say it as an aside, it makes me sad to think that some people it's a hoax, because it's one of the most glorious things that the human race has ever done. And if you really don't believe it's true, I think that's a sad thing. So let's move forward and help people understand the rationale as to why we know that it was not a hoax.
So the Apollo project involved over 400,000 engineers, scientists. There was a lot of people involved. And there were a lot of aerospace companies involved. I mean, the first stage, Saturn V, was built by a major aerospace company. And they also had contractors too. Even the capsule, that's the next slide, was designed by North American Aviation and actually built here in Southern California. So there are a lot of people involved, and perhaps you have relatives or even yourself at the time were involved in building this incredible space capsule that housed the 3 astronauts that went to the moon. Even the lunar module that landed Buzz Aldrin and Neil Armstrong on the moon. It's made by Grumman, and in fact, just a couple of days ago, we had engineers from who designed the descent engine of the lunar module. And so why would all these people put all the education and expertise on the line to build something so complicated and have it, and then suddenly say, someone says, no, we're going to do it on a film stage.
Right.
It's just, yeah.
And it's pretty impossible for 400,000 people to keep a secret. So if you were going to fake the moon landings for the public, you'd have to fake it for them too, which means all of their data, all of the things they were looking at on the screens, all the hardware that they were building, it was just for nothing? That's not actually at all feasible. You know how hard it is to keep a secret. And somebody would have leaked that. I think there would have been a lot of motivation to do that.
And to have TV broadcast over the 8 days of the mission to over 600 million people around the world.
So, of course, everybody saw it launch. This was not faked. There were people down at the causeway, many, many more. So if they're going to build a big rocket that was capable of taking people to the moon, that took, as you said earlier, 12 seconds. It's a huge rocket, very heavy, but enormous thrust. Enough thrust to get people into Earth orbit and then off to the moon, lift all that weight. You know, you're not going to do all of this and then fake the rest. And then there's a point when the rocket, after it orbits the Earth, has to be put into a trajectory, on a path to the moon. And this is actually some imagery taken by civilians with telescopes of the firing of that rocket. There's a drawing at the top, people looking through telescopes drawing, but there are actually, as you can see, some photographs. So we know not only was all that telemetry, in other words, all the radio signals saying, yes, we're firing our rocket to head off to the moon now, but people, civilians, saw it. You could see it from Earth through a telescope, and people did see it. So that wasn't fake. So far we know we had to get all of that done. And then as part of that trip to the moon, they had to eject off those sort of plates. You know, they had the capsule or the spacecraft had these little plates that came off and had to be ejected off. And sure enough, here's a photograph, again by a civilian, of those 4 dots coming off the spacecraft. So everything exactly as described, everything that's in complete agreement with what was going on the radio with NASA, and people able to photograph it. At the same time, the Soviet Union had ships in the ocean that were capable of picking up the transmissions from the moon, or from the missions, and they tracked those transmissions as the mission progressed. So the Soviets had every reason to say, oh no, there are no signals coming from the moon or from a spacecraft on the way to the moon. It's all fake, because of course it was a competition with the Soviets, and if it were fake, they would have been the ones to say that it was, but they didn't. They detected the same signals. There absolutely were radio transmissions coming from people on a mission to the moon, even as recorded by our arch nemesis at the time, the Soviets.
And there were thousands of amateur radio personnel who can actually intercept those radio signals from the moon as astronauts broadcast it, and from mission control too, because it was on a frequency they can actually detect.
So it was wide open for everybody on Earth to see. It wasn't going through some secret channel that was being, manipulated by some nefarious people. Then there's the question of the many sets.
That's right. Oh, sure. I mean, this set, it would require, many tons of dirt to be trucked in. I mean, these would have been huge sets, bigger than, say, Cleopatra Sesame DeMille's set, which was giant. But this would have been miles, and to haul in all this dirt. And how do you make the sky black as well? So,
yeah.
This shows. This is from Apollo 17. But this showed lots. Basically making those mountains, creating deep craters. That involved a lot of effort, and a lot of people would have been involved to bring all this material in to make a set on this scale.
That's right. So the effort to build the sets that they needed, and there were several different landing spots, trucking in all that stuff, and then destroying the sets afterwards so no one would find it, and doing it all in secret, that would be virtually impossible. I've heard the quotation that it would have been, they didn't have the technology to fake, through CGI, a moon landing. They had better technology to actually go to the moon than to fake it in terms of a computer, well, they didn't have computer-generated imagery. So one of the big questions that people have is, how come we don't see any stars?
That's right, and you've seen in many artist impressions from the Apollo era that the lunar sky is filled with stars, and yet all these images that we've gone back from Apollo show a pitch black sky. Where are all the stars? What's going on here? Well, it's a matter of basically understanding what basic photography is and what kind of exposure rates you're using in photography. So here's a quick demonstration. This is the front of our building taken at night, and this is a very short exposure, just short enough to capture the brightest portions of the observatory, which are basically the lights, but nothing else is visible, you know, except for the parts that are illuminated. Now, if you take a little longer exposure, it brightens up a bit, and you begin to see something in the sky. You begin to see clouds. And if you expose for much longer, you can see clouds better. But look at the front of the building, and it's now overexposed. So, we can go to the next slide.
Yes.
This is really totally exposed. And so now you can see, if you wanted the clouds, you just overexpose and not have the building and basically, you want to expose for the sky, you just take a longer exposure, but your building is all washed out. So, so that's kind of what we're seeing happening here. And basically, here we are just kind of raising the exposure rate, and we're just seeing...
Let me interrupt and just say on the right is a simulation of what kind of image you might get with different exposures. So you're collecting photons from the surface of the moon. It's the brightest thing. And from the Earth, which is also bright.
That's right. And here we're not collecting that much, and so. But as we go, as we expose longer, you notice the lunar surface is getting bright, and the Earth is bright, and then eventually, you can capture the light of those faint stars. But then, look at the moon. And the Earth's overexposed. So the astronauts were really not exposing for the sky. They needed to take pictures of the surface at the right exposure. So that was why they couldn't expose for the stars. The stars, even though they were in the sky, they were far too faint to be captured. And of course, you know, if you were wanting to do that, you point your camera straight into the sky and expose for a long time to capture the faint light of the stars. And then you have nice starry pictures. It's just like what astrophotographers do in the national parks, take these beautiful pictures at night using long exposures.
So we didn't travel all the way to the moon just to take pictures of stars. So, so that, I hope, convinces you on that. Then there's the question about why are the shadows in different directions? That sort of suggests maybe there are multiple light sources and it's a movie set with multiple light sources. Well, we actually see this all the time. This is taken right from our sidewalk, walking up from the Greek theater there. And you can see that there's only one source, the sun, but you get different angles depending on the local terrain. So when you're on a hillside or there are, you know, bumps and wiggles on the terrain, you'll get different angles. Those aren't parallel either, but it's because it's all has to do with perspective and the terrain. So it's not multiple lights. You can do this at home, and you'll see that you'll get shadows that are not parallel, even from one light source. I mean, if I had one light source and two things here, the shadows would go out in that direction, not parallel, right? Now the moon, of course, or the sun is much further away, and you should get parallel lines, but the terrain makes that not true. Another convincing piece of evidence.
Yes. So this is a reflector. Basically, it's a laser reflector left on the surface of the moon at Apollo 11, but there were 5 others from the other Apollo missions left on various sites of the moon. And basically, this is a reflector containing 100 corner-type mirrors. So if you shine a laser beam from Earth, from an observatory, and hit it at the right spot, you get a reflection, return reflection from the laser. So it's really interesting because you really have to aim your laser at the precise spot. If you're a little bit off from the laser reflector, you have no return light. You got to hit it spot on. So when we did that at the various sites, Apollo sites, the laser light just came back. And this was actually done many years later by the Mythbusters, and they used a laser from Apache Point in New Mexico and shone a laser at the Apollo's, one of the Apollo laser reflectors, got the return signal at precisely the area where they landed. So they kind of myth-busted that one.
Yeah, so you can't, you know, if there is no laser reflector on the moon, you're not getting it. So they did leave it there. So something left it there, and we saw the astronauts deploy it in the video. So it's all really there, and really true. Then there's an issue, some evidence by the moon rocks they brought back. The first thing to say about it is that the kinds of rocks they brought back on the Apollo mission are not rocks you find on Earth. There's no way we could have faked these and somehow created these rocks that are nothing like Earth rocks and then said, oh, these are moon rocks. And in particular, there are these little, I guess I'll turn this way, these little spherules in here have little tiny micrometeorite pits. And that comes from little tiny bits of dust striking rocks on the moon, striking these little inclusions in the rocks, and leaving teeny tiny pits. On Earth, if you have a micrometeorite, a piece of dust flying through space, and it comes through Earth's atmosphere, it burns up. So you don't get micrometeorites hitting rocks on Earth. They burn up in the atmosphere. On the moon, there's no atmosphere, so you get these little tiny dusty micrometeorites peppering the rocks, and we see that in the rocks we bring back from the moon. Oh, this is an interesting one. The Japanese Space Agency recreated, based on their own data from their satellite measuring the moon, a satellite called Selene, what the landing site, Apollo landing site, would look like, based on their own laser altimeter, based on what they know the local terrain to be. So again, this is the Japanese Space Agency. On the left, you see their 3D recreation of what the landing site should look like. And on the right, you see the Apollo landing site. I guess this looks like one of the ones with the buggy in it, so maybe Apollo 15 or something. But you can see they're virtually identical. So that picture on the right was taken almost 50 years ago. That recreation on the left, decades later, and from their own data, they show that the images we took 50 years ago match exactly what the moon looks like in that spot. 50 years ago, we didn't have data on the moon. We could not have faked that. We could not have made that up. We didn't know. The only way we knew is because we went there and we took that picture. And now later that we have very high resolution data on the terrain surface of the moon, we see that in fact it's identical. And again, that's not an American agency. It might be somebody who invested in wanting to say, hey, they didn't do it, we're going to do it. But in fact, it matches. Following that, there's a mission that the United States launched called the Lunar Reconnaissance Orbiter. And here's a little diagram of it circling the moon. It was launched in 2009. It's still active today. And it has very high resolution cameras that image the surface of the moon. And look at that. Those are all the Apollo landing sites. And you can see, I guess we'll just zoom in. You can see they're all there, right? You can see the little spot where the landers landed, right there, there, there. That's where the dust is blown out and the lunar module sits still today on the moon. Here's a close-up. You can actually see their footprints. And in this case, they're buggy prints, you know, the wheel prints from when they were driving around on the moon. So
double trails.
Double trails, yeah. So it's exactly, and they're exactly where the astronauts went. And that's a picture of the moon taken now. So those trails are still there. It's exactly what they did then. It's still there because there's no erosion or wind or atmosphere on the moon blowing it around. And those sites are basically undisturbed. And sure enough, that's what they look like. So it's just what you would expect. Yeah, there's the descent. You can see some of the scientific equipment and so forth. So we actually see, we can image the landing sites from or lunar orbiting telescopes today.
And you can just tell by the shadow from the lunar descent module. Just by the length of the shadow and the height of the sun, you can calculate how high it is, and compare it to the actual lunar module descent portion. So
and it all matches.
It matches, yeah.
How many of you are getting convinced? I hope so. Then one question that's asked a lot is, well, if we went, why don't we go back? Why haven't we been back? Why did we stop? Now, why did we stop is a more philosophical question, but here's one of the reasons we haven't gone back. It cost a lot of money. And all of the Apollo program and the effort to put a human on the moon really launched in 1961, unbelievably, less than 3 weeks after Alan Shepard launched into orbit. Alan Shepard was the first American, pardon me, he did not go into orbit. Alan Shepard only flew a suborbital flight up into zero gravity and down into the ocean, the Atlantic Ocean. So he didn't even orbit. And less than 3 weeks later, the president, then President John F. Kennedy, went to Congress and said, I want money to put a man on the moon before the end of the decade. And it took a lot of money, and he had to build a real consensus. He had to get everyone behind it. Now, the times were different. We were in the depths of the Cold War. The Soviet Union was definitely leading in the space race. They were the first to put a satellite in orbit. They were the first to put a human in orbit. They were first to send a spacecraft to the moon. So we knew that we had to catch up. And he felt this was essential in proving the strength of the American system. He actually, many people don't know, he actually suggested that we do it jointly with the Soviets. But that isn't how it worked out. It was just an American program, and it took an enormous investment. So this bar graph shows you the percentage of the federal budget that was spent during the period of Apollo. And the country was behind it, the Congress was behind it, and we spent a lot of money to do it. A large fraction, well, if you call 4% large, but it's more than today to make this thing happen. And then as the goal was achieved and the mission was accomplished, so to speak, the funding dropped off, and the real goal was not to go and start living on the moon. The real goal was to prove we could do it, and we did it. And so that was a conclusion of the mission. NASA went on with the space station and the International Space Station. Since we've had missions to all the planets, and even some that aren't planets, like Pluto. Sorry if there's any boo hiss on that one. And so NASA's doing other things with some of that budget, but they aren't putting people back on the moon. But we were there. We've left our footprint, and it really, really did happen. I imagine that many of you, how many of you were alive and remember the day we landed on the moon? Yeah, it was a pretty emotional and fantastic moment. And so, especially for young people today, and especially in an environment where you don't know what's real anymore, it's much more prevalent today than it was then, I hope you will take the effort to try to help people who don't really know if it's true or not understand that it really, really did happen. So we have just a few minutes for questions. We'll do our best. As I say, this is not our topic. We're filling in for Dr. Reitzel. But if we have any questions, I'm happy to try to answer them. Yes?
It's for those people who, at the time or even today, still believe that this is all a hoax, what could possibly be their motivation?
What could be the motivation for somebody who wants to believe this is a hoax?
More likes on YouTube? I don't know.
I actually throw that to the audience. What do people think? Maybe you folks know people who think it's a hoax, or maybe privately. What is the motivation? Why don't people believe it? Yeah.
Because of fake stuff on the internet.
Because there's so much fake stuff on the internet. Uh-huh.
Because people just Photoshop things on their photos and say, oh, look, I found a whale in the pond or something.
Yeah. So this young man is saying it's so much is photoshopped and faked on the internet now, they can... oh, I'm sorry, it's a young lady? I'm sorry, these lights are in my eyes. So, who knows what to believe these days? That's dangerous. It's very dangerous. We need to be able to tell the difference between what's real and what's true. Any other thoughts about that? Yes.
So I'm wondering, how much money have we, I won't say wasted, but kind of wasted on getting all this data to prove that that the moon landing did happen, when it probably won't convince the people who believe it already?
Well, I don't think we spent the money to get data to prove it happened. We spent the money to have it happen.
Yes.
And
how Japan made that free representation, did they make it specifically to prove the moon landing, or just in general?
oh no, so this gentleman's question is, how much money have we spent and perhaps wasted trying to prove this? And I replied saying that, we spent the money to do it. Japan all of these missions that go to the moon to study it want high detail. We want to learn about the moon. It's part of our history. And so we have the data, and scientists were curious, could we recreate the landing spots? And that was a pretty straightforward project. So it wasn't a terribly expensive thing to do. One of the important things that I think is important to remember about Apollo is that it had the goal of demonstrating that we could get together and develop a technological project that would demonstrate American preeminence in space, and not just on the moon, but that we had the industry and the engineering and the technology and the know-how to pull off what was pretty much a miracle, you know, an outrageous goal, and do it in 8.5 years from the time that Kennedy first called for it. What perhaps a lot of people don't know is that the return on investment, in other words, the technologies that came out of it, the industries that were spawned out of it, have an enormous return on investment. Very conservative estimates are maybe for every dollar spent on Apollo, between $10 and $20 back into the American economy. Some of the more extreme estimates are up in the world of $100, $200, $300 back for every dollar invested. So I do hear that a lot, the idea that why are we spending money up there? Well, we're not spending it up there. We're spending it here on people and families and technology development that went on to spawn whole industries and sectors: computing, communications, miniaturization. We wouldn't have cell phones today were it not for the Apollo era, because they had to take computers that were the sizes of rooms and make them fit and be light for a spacecraft. So the drive for that has had its more than many-fold return to the American economy.
I just kind of meant like their time and effort and money used to give all this data that proves it separate from. I understand that. The entire program has benefited us immensely.
That's right.
As me just proving these small segment of the population.
So we have time for maybe one more question. I think I'm going to try to get, yes, up in the corner.
Do we know how much of the federal budget today is spent on NASA? compared
Let
to
me
the
look
budget
at that
last
slide. Less than about half of 1%. Yeah. And, you know, I'm sure that there will be calls to Congress as the Artemis program, the subject of our next talk at 2 o'clock. I'm sure there will be calls for more funding, and that will be an interesting discussion within the Congress. So we have yet to see how that will unfold. But yeah, it's far, far less than the 4% during the Apollo era. So with that, I thank you for your attention. I just do want to warn you that if you say anything in front of Buzz Aldrin that you don't believe he went there, he's going to hit you. So, so be careful about that. And I hope that you have a beautiful afternoon at Griffith Observatory, and thank you for coming.